Hey, everybody. Thanks for joining us today. There's some exciting stuff going on in the world of LiDAR lately. Boy, there's been a crazy couple of months on seeing new products come out. And today we have Rock Robotic with us. They're going to talk about their platform. You got the DJI stuff that was announced recently, all kinds of cool, interesting things going on with LiDAR. So I'm not a LiDAR expert by any stretch of the imagination, and these two guys are. So I'm going to turn it over to Alex and Harrison, and take it away. Why don't you start off by, well, introduce yourself, and then tell us a little bit about why we might want to be interested in LiDAR.
Sure.
Absolutely, Carrie. Yeah, thank you very much for having us on this webinar today. It's really exciting to be sharing LiDAR with the world and seeing all of this awesome accessibility of LiDAR to people that own smaller drones instead of flying some of these very large fixed wings or very large drones. Now we're starting to see it happening on systems that we can fly pretty easily. So my name is Harrison Knoll, and my brother and I, Alex Knoll, are the founders of Rock Robotic, and I'm also Indiana Drones on YouTube. So if anyone wants to learn a little bit more about LiDAR, we have a pretty cool YouTube channel. I hope you just go over there and click on it, Indiana Drones. And today we're going to talk a little bit about our latest.
That's a great plug, and I should have mentioned that. But yeah, if you guys are interested in understanding LiDAR, seeing how processing works, different products that are out there, definitely check out Indiana Drones. It's probably, I mean, talk about a niche market on YouTube. There's not a lot of competition for LiDAR info on YouTube. So check that out at Indiana Drones. I think you'll like that kind of content if that's the kind of nerdy, geeky kind of guy that you are. So go ahead, guys.
Yeah, I mean, definitely do check it out. And today on this webinar, we're sharing our latest product, which is called the R1a, which is a LiDAR system that is being sold at a very reasonable price. And it goes on the M200, M210, M300. If you see me on LinkedIn, we put it on the Inspire just the other day. And kind of going along with the LiDAR sensor, we have a LiDAR Cloud. So now for the first time, you're going to be able to simply, actually, check this out. So if you guys can see me, I'm actually on a job right now in the Mojave Desert. So I'm flying an archaeological survey with our new LiDAR sensor, and it's right over here. So I can grab that and bring it up. And then once I get done flying, I'm just going to grab this USB stick. I can't see what I'm doing. Drop that on the ground nicely. Then you just upload this to the cloud, and all your data gets processed, and all your deliverables are made for you. So it's kind of a new way of doing it. And Alex, do you want to introduce yourself?
Yeah, absolutely. So as Harrison mentioned, Alex Knoll, we've been doing LiDAR and photogrammetry services professionally for 5+ years with Aerial Insight Services. So we've been all over the country, all over the world, doing LiDAR work, Papua New Guinea, Ecuador, China, actually. Yep, we were literally just in Alaska. We landed late Monday, so this is our second full day back. Harrison's already out in the Mojave Desert doing another job, but we were in Alaska for 2 weeks, which was just amazing, doing a big LiDAR job up there, which we can talk about a little later if you all are interested. But yeah, so we've been doing this for quite some time, and we built Rock Robotic to really fit the need in the industry, which is reasonably priced LiDARs that are a good size, that can be carried on drones that are not, the real big boys, and can be flown on the M200, M300, maybe even the Phantom. We're testing that right now, or Inspire. Inspire. Sorry. Maybe even the Inspire, which would be just amazing.
What's the difference between photogrammetry and LiDAR?
That's a great question, Carrie. So actually, we've been doing both photogrammetry and LiDAR. And they're different tools for different use cases. So anytime that you have a bunch of trees and you still need to get a digital elevation model, and you need to get a topo or terrain, this is when LiDAR is going to be really useful. So the LiDAR is an active laser scanner, and so it actually sends out laser pulses, and these laser pulses can actually penetrate through the foliage and see the bare earth, the ground below the trees.
Not
So
by
in
burning
this way,
holes in the leaves.
not by burning holes. So actually, there's a cool video. I'm going to plug it again on Indiana Drones. We share how this works. But basically, in short, it's just like my rule of thumb. I've been doing this for, on the drones for about 5 years. If you're walking through a forest and you can see some light on the ground, the laser is going to see the ground. So that light will come down and actually kind of go through the holes and cracks between the trees, between the leaves. And some of that light will hit the ground and bounce back up to that sensor. And so this brings up a very, very important topic in the field of LiDAR. So when it comes to automotive grade LiDAR, all the way up to survey grade LiDAR, one of the big differentiators has been the number of returns that you get. And this is basically, you send out a laser pulse, and that laser pulse has the opportunity it can hit a tree and then keep going a little bit of it, but that first collision will bounce back to the sensor, and that'll be your first return. Some more light keeps going, hits something else, bounces back, second return, and so on and so forth. So it's these multiple returns, which is what enables the LiDAR to actually see through those cracks in the trees really well. But big difference between photogrammetry and LiDAR. The LiDAR is an active sensor. It's directly georeferenced, meaning that your trajectory of your laser scanner has an RTK, so you're calculating where the drone's flying very accurately, and you're directly projecting those laser points onto the ground. Whereas in the photogrammetry case, you're taking key point matches between adjacent photos, and you're computing where they're located on the Earth. So it's kind of one way with photogrammetry, you're kind of inferring that location. So in this case, on the LiDAR, you're using these ground control points, and you're going to tie that very fixed to the ground. And then in between your control points, you can start to get some accuracy drift. It's not so bad. It's really, I use photogrammetry. I'm flying a photogrammetry mission right now, so I definitely still use it. But LiDAR is just something that you're going to be able to get a very accurate, detailed, three-dimensional model, even when you have trees. So that's most of our use cases. Most of our use cases is producing digital elevation models and contours. So for greenfield construction, we also do a lot of power lines. So if you do things like wires, the photogrammetry oftentimes will have you can do it. It just takes a lot of photos from a lot of angles. And if that wire is swaying at all, it's gonna not really resolve in the photogrammetry. So the LiDAR will directly pick these up and be able to see it real easily.
So that was actually kind of my next question is, who is the primary users of LiDAR?
So traditionally, it's starting at the top. You had government organizations. So whether they're looking at, digital elevation models, so the elevation of the entire country of the United States or the world, big government agencies would pay for this. And then it came down into the construction industry. So a lot of architects and design firms, they're going to ask for a LiDAR scan, or you can actually sell them a LiDAR scan in place of a traditional survey right now. And that's what we've been finding a really good niche in, is that instead of sending out a 2 or 3 person team of surveyors to go walk through the woods and lay down, control and then lay down a bunch of points, either using a total station or RTK, you can actually fly. And what we found is that we've been able to fly in one day the amount a 3-person survey crew would take almost 7 weeks to do. And in that case, we charge those 7 weeks, and we just do it in one day.
That's a beautiful model.
That's our little secret. But with Rock Robotic, we want to enable people to do exactly what we've been doing and making money off of. And so that's kind of the other side of the Rock Robotic mission, is that we want to be a source of information and knowledge and just help you get deliverables. So you can buy this system, and using the Rock Cloud, you're going to get contours that you can deliver directly to your clients. You don't have to worry about learning how to process a bunch of LiDAR data. We've learned that, and it's a pain in the butt, but that's what the cloud does. And so that way you don't have to worry about it. And, I've been using it now myself too. So you can see here, Alex is sharing the screen. And so this is a example flight that we did. And you can see that these are contours, but this is located underneath all those trees. So all the trees and all the vegetation and buildings, obstructions have all been extracted away from the data set. And these beautiful clean contours have been generated. So that's the power of LiDAR. It really is. And the other side of it, for everyone watching who's interested in possibly getting into LiDAR, it's a real good way to differentiate yourself in the market. So there's a lot of people doing photogrammetry. If you have LiDAR as a capability, you can really differentiate yourself and start locking in a lot more new jobs that are fun. Come out to this, it's like 100 degrees out here. My phone overheated, my laptop overheated, my inverter, I'm charging a bunch of M200 batteries right behind the screen here.
But I mean, we do a lot of webinars on photogrammetry, a lot of stuff with Pix4D. We definitely move a lot of systems designed for that, like the P4 RTK, you know, super good seller of ours. And that's been a great enabler, allowing people to get into something that used to be a lot more expensive with the level of accuracy that they can get now. And now with this new generation of LiDAR systems, it's going to open up a whole nother set of markets for drone service providers.
It certainly is. And it's really, I mean, we've been super happy to be a part of this whole evolution. I mean, in our past working, we've worked with all the other LiDAR vendors. So I personally have built the vertical takeoff and landing system for Phoenix LiDAR, and I'm the trainer for that system. And I've flown that all around the world. And then I've worked for Green Valley. I've flown the LiDAR Swiss and Yellow Scan systems. And I've been a trainer for a lot of these systems. And really, carry on to the biggest issue, and if anyone out there watching right now has flown any systems, it's that you require a lot of gear to go along with you. So that's why we made this R1a, because all I have to do is log into it with my cell phone, and I'm up and flying.
Well, yeah, I mean, traditionally, a LiDAR UAS package is like a Sprinter. You know, it's not, you know, it's not a Prius, it's a van of equipment.
Yeah,
okay, in fact, I am in a van right now.
We were, so this Alaska job that we were talking about at the beginning, there's kind of two parts to it. For a certain part of it, we had the opportunity to fly the Regal Vux sensor. That required a really big drone, the Alta X, one of the biggest, you know, multi-rotor drones you can get. That required, you know, a whole team of people to, you know, get that drone in the air, keep it in the air, whole base ground station, you know, big antennas, lots of equipment, and it was, you know, we flew it everywhere we felt comfortable, but there were certainly places in Alaska where we did not feel comfortable flying it. And in fact, we had to fly the R1a at those sections because it just couldn't get it. So could we have flown the R1a on the whole job? Yes. But for, you know, this particular client, they wanted the, you know, Regal, the big Regal system. So we flew that as well. And just like the comparison, seeing, you know, flying both sensors in the same day, kind of like really big Regal system to what Harrison is showing there, the R1a, it's quite a big difference.
Excellent. So do you guys want to talk about the R1a now, or?
Certainly. So this right here, this is our R1a LiDAR sensor. So we are based in the US. This is a American-made sensor here. It has the Livox on it. So in my past, I've flown all of the Velodyne, Quanergy, Regal systems, and this Livox sensor is really freaking good. Very impressed with it. And then the kind of guts inside of it is a tactical grade inertial measurement unit, inertial navigation system, INS, and then it has a Novatel GNSS system. Basically, what you're gonna get from this is you're gonna be able to connect into the Skyport. Right now, I'm actually connected into the DRTK system, so I didn't even use our antenna that I provided. I'm just using the DJI antenna, and then from this, you're gonna get about 5 centimeter accuracy on your whole survey area when you fly at about 60, 70 meters. I mean, we've flown, I've gotten 2 centimeter accuracy flying a little bit lower, and I'm still kind of shocked by the accuracies we're getting compared to, cause I own the Regal Minivox as well. So I benchmark everything against that, and it's looking pretty sweet. We were supposed to be flying the Regal today.
Alex, do you have a picture that shows it in a larger size there? Because the thing that I don't know if people grasp looking at the image is this does not look like a traditional LiDAR with the big drum on the front.
Right, not at all.
How is this different than the spinning drum laser?
So this is doing
LiDAR?
Exactly. So yeah, mostly the automotive LiDARs and also some of the aerial LiDARs. It has a mirror that spins in a full 360 degrees, and so it's actually shooting those laser points in all 360 degrees. And then in post processing, you narrow that down to a field of view about 60 degrees. So this sensor is actually doing a 40 degree by 40 degree, like a camera. So the camera that's on it is actually matched up to the laser profile as well. So the camera images directly colorize and georeference onto the laser points, and it has that, matching field of view. But this is very different because you'll see some sensors, they'll quote how many points per second it does. But then what you have to actually do is divide out, if you're only using 60 degrees, then you have to take away, 5/6 of the laser points. Yeah, exactly. They're going to be going up in the air. I ain't seeing anything. So this has 100,000 points a second, and they're all pointed right at the ground. So it's very unique.
Advantage? Is there any advantage to that drum style with being able to shoot more horizontally away from the aircraft?
So yeah, totally. There is. And so we're actually in the process of building a little quick snap mount. So that way you can take it from pointing straight down, you can point it straight in 45, and you can go 90. And so in this way, you're going to be able to capture facades, sides of buildings very easily. And that is one thing that we've been, working on. But even still, we have some data sets we'll be sharing on our cloud that we did a glacier, and we also did this quarry, and they had vertical walls. We still got great data on it. So I'm not too terribly concerned. And even with the ability to move it, I don't think users are going to do that so much. You mentioned earlier about this new DJI L1 LiDAR, and I think that's a great thing to be bringing up because I would say right now, as it stands, our system is about the same price as that, and we have a little bit better IMU inside of it. So technically, the data is a little bit better, but I'm sure the data is going to be great from that L1 as well. And that's why we have our Rock Cloud. So our Rock Cloud, we're processing all of the DJI data as well as our data, as well as everyone else who has LiDAR data. So that way, we're going to bridge that gap for all the users who want to buy any one of these systems. So they can just use it, fly it, upload, and get reliable, good quality results like contours, topographic, digital elevation models, vegetation, power lines, all of these different verticals that need specific deliverables, given to them. That's what our cloud is going to be delivering for everyone.
So it seems like right now this revolution or evolution or whatever you want to call it in LiDAR has two main components. The hardware, which has always been, let's say, not affordable or not inexpensive, upwards of $150,000, $180,000. So there's the hardware side, and then there's the software side, which has also been extremely difficult to learn with a huge learning curve. And often, depending on the hardware you go with, you may have to run 3-4 different pieces of software to end up getting your final result. So the Rock Cloud is addressing that second piece.
Yeah, exactly. So I'd say there's usually when you would buy a LiDAR from anyone that sells it today, other than us right now, they're going to sell you some LiDAR processing software. But really, kind of what I call this, it's actually LiDAR pre-processing software. That's all the software that you need just to get to the point where you can start doing the processing of the LiDAR data. So it's just getting you to have this 3D LAS file. And usually as a LiDAR processor, so there's companies that do this, engineering firms and whatnot, that's where they would start. So they would start having this LAS LiDAR data, and then they would do the ground classification, the contours, or looking at different, cut fill for earth moving projects. So that's typically where they would start. And so that's yeah, exactly. The Rock Cloud is going to be doing all of that as well as that final step as well.
Yeah, certainly what we've found from working in this industry for 5+ years and talking to customers and clients of ours is that, a lot of places, a lot of people can fly drones and acquire the data just fine. If we make it simple enough, they can do that. But that LiDAR processing, before the Rock Cloud, it would take effectively a PhD in LiDAR processing to get out really quality deliverables. And we've been doing it for 5 years, so we understand the trials and tribulations of doing it. It's not for the faint at heart, and most people don't want to do that. Like, that's a big barrier to entry for a lot of customers, is the difficulty of getting real deliverables out. So what we wanted to do is make it super easy to say, listen, nobody cares about LiDAR data. What they want is that final deliverable. What they want is those contours that they can plug into their CAD software. That's what they want. They don't care about anything else. And so how do we make it as easy as possible to go from acquire this data, and I'll show you quick things real quick. So we have this docs page, docs.rockrobotic.com, where we go through how to mission plan, all of the information that you would need to do to actually acquire that data and upload it to the cloud. So we give you all that information. You can go on there right now and take a look at it. We have a community page where any questions, obviously every location that you're acquiring data at, like Harrison's out in the Mojave Desert, a lot different than when we were in Alaska last week, just a lot different terrain. So people are gonna have questions about, what's the appropriate AGL to be flying at, all different kinds of things. And so we're answering those questions up here, trying to make it as simple as possible to kind of get that help that you need to acquire that data. But once you've acquired that data, then you can upload it to the cloud, and then it's just, click and say, I want contours, a DEM, because that's what the end customer or your company or organization wants, and then you get that. So that's what we're trying to do, make it vastly simplified for the end user.
So I want to say one thing on that, Alex. Can you pop over there to the cloud really quick? Just go to the home page. So this is something else that's been a big pain in the butt for me for the past 5 years. Yeah, go on to the home page. So I don't know if anyone else is familiar with this, but I have hard drives and hard drives and hard drives strewn about my office, labeled. They have random names on them. I didn't make all of them. And so just one thing of just data organization and backing it up, it feels really nice just having these projects, knowing that the data is backed up, and then you can click into the project. So first thing that happens when you upload your data is you instantly see your trajectory. And so this trajectory is where the LiDAR flew and captured the data. And then you can actually select in that trajectory, what do you want processed? So you can cut out all the stuff like taking off and landing, because it's still recording data there, but oftentimes you don't want that in your data set. And then the viewer automatically generates for you. So you can see, you want to click on the viewer, Alex?
Maybe it's delayed for you.
Yeah, it's a little delayed for me. That's okay. So yeah, then the viewer automatically generates this cloud viewer, so you can share this with your clients right away. And this is available as soon as the first step of the data starts processing. And then from here is when you would do things like power line classification or the ground contours and this kind of further deliverables. So that's been really nice for me, just having this to share with clients. It's been helping us win more jobs because it's easy to, when you show a client this, they just go, wow, that's beautiful. And you go, yes, they just get it. It's just, they understand. So it's actually helped us win a lot of jobs. This is an example of classified, this is a little
Substation?
small substation. Yeah, exactly. So we have the conductors and insulators and structures all classified for this customer here. And we were able to share this data set.
Yeah,
So
so if you create an account on cloud.rockrobotic.com, you'll have access to all these sample data sets as well. So you can come in here and kind of take a look at everything. I like the airport runway to kind of see the kind of the density of points and the height of points. So like it really tells you the accuracy when you do a cross section on this data. Bixby Bridge one just looks amazing. This is just a really cool cool use case of getting bridges. So I'll kind of zoom around here. My internet's a little
for anyone who's familiar with Pix4D Cloud, this is the equivalent, but for LiDAR data.
yeah, exactly. And so just like Pix4D as well, so we have different plans. And in our basic plan, we're just processing the data and just hosting it, and you can share it. And then on all the plans, you can always a la carte anything you want. But then we have a kind of a pro plan, and then this is where we're doing ground control points, which typically in LiDAR is more like ground checkpoints more than control. It's used primarily to check the accuracy, not necessarily to actually, get that accuracy. The data already has that. And then also all these deliverables and showing the contours and this is available on the pro plan.
So one of the things you talked about early on was this is like the fast track to creating the deliverables for a customer. What are those deliverables? I mean, what is a customer looking to get out of your data that you're going to provide?
So 9 times out of 10, our customers are going to want to have contours. So that's almost always a deliverable that we're doing, even if the job doesn't need that particularly. They're going to get contours, which they can then open up in their AutoCAD software, or their, if they're doing BIM or this kind of stuff, they put it in their software for that. And then they'll use that to kind of build their construction models off of. But we've also, for the same thing that generates contours, we have a digital elevation model and 10 models. And these 10 models and DEMs, the customers want those to do hydrology, hydrological work, so simulating water flow, coastlines, a lot of this work. And then we also do some tree stuff. Talk to us if you guys want to do that, and we can discuss that. It's not built into the cloud. We'd have to actually process that ourselves. But yeah, so for the most part, it's those contours. And whether they're doing a earth moving project, because some people get paid on how much earth they're actually moving. And so this is an easy way to quickly calculate that. Or if they're going to be doing a greenfield project, and so they have a bunch of trees, they need to build a new road, new building, a facility, you can give them that contours, which then they can start designing their projects on. Yeah, we've done like laydown yards, where we can just get out there and they can start planning where they're going to put all their equipment. So
yeah, Harrison's out at an archaeological site right now. That's literally where he's at. So in that particular job, what they're really interested in is there's lots of Native American like artifacts and things around, and what they really want to get is kind of that point cloud view of like, hey, can they see anything? Since we can see really defined like structures or other things, on the ground, that's kind of difficult with photogrammetry. This gets really precise, edges to a lot of this data. That's what they're using it for in this case.
Yeah, that actually brings up a few things about right-of-way inspection. So a lot of oil pipelines or transmission power lines, they need to do right-of-way, which is basically looking at vegetation encroachment on their structures. So being able to measure that and see all that, that's also a deliverable that we get asked for a lot. And yeah, it's archaeological site. And we also were down in South America in the rainforest last year. and we were actually penetrating through the canopy of the rainforest, finding buried oil sites where a previous contractor 30 years ago had a large ecological disaster, and they just thought they can cover it up. So 30 years later, in the rainforest, we're able to still find these buried oil sites in the Amazon rainforest. Kind of crazy.
Super cool. What we've seen a lot lately, in our business at Multicopter Warehouse, is more and more companies purchasing products like the P4 RTK for photogrammetry to do that in-house. Do you see LiDAR being moving that direction at some point, or do you think it's going to reside more with a drone service provider for the time being?
Clearly, Kerry, that's why we're making this product, because we're getting replaced. So we got to do something here, guys. No, it's so I've seen this yo-yo where so in the utilities, I saw it all go in-house for a little bit on several big investor-owned utilities, and then I saw it go right back out of house. So I think there is people bringing it in, but then they quickly realize, hey, we're not an aviation company. We run electricity and power lines. Why are we doing all this other stuff? So then it goes back to outsourcing. So I think it's going about 50-50. There's a lot of room for the small, surveying groups, 3 to 5 person companies to get one of these systems and be making great money using it in their surveying projects. So I'd say it's going to be mimicking basically what happened with just surveyors in general with GPS and total stations. Some of that came in-house, but there's a ton of small and medium businesses that's all they do, and they really thrive off of it.
Good. We have a couple of questions. One's the hardware, but let's circle back to that later. But on this one, JP is asking, if you purchase the R1a, are you able to process the data offline yourself, or do you need the cloud subscription?
So you do need the cloud subscription. So all of the software is hosted in our cloud. So yes, you do need the cloud subscription.
Now, if you had all the other software like LiDAR 360 from Green Valley or something else, could you use other tools to process the R1a data?
Yes, you can. And that's actually so this comes back to what I was saying earlier about this difference between like LiDAR software in the pre-processing sense. So that pre-processing is what we're doing in the cloud for everyone. And that's something that you wouldn't, honestly, you wouldn't want to be doing it yourself anyways. We just do that, but then you can, at any step in that process, you can download those deliverables. You can put it into LiDAR 360, into, any sort of software that you want to do any further analysis on at any time. And Alex, you can actually click on that screen. There's a tab called deliverables. So in that deliverables, you'll see the LAS. And for this use case, we had contours and a digital elevation model as well. So it's all available there. So anytime you can just grab that and do any processing you want.
Yep. So if you don't want to get the ground classified data and contours from the cloud, then yeah, like Harrison said, once that LAS is created, you can just download that and put it into LiDAR 360 or any of the other point cloud software.
Okay. Now you said you're the Rock Cloud. So let's look back up. So the R1a is standardized data that can work with other pieces of software, and the vice versa is true, right? So other LiDAR platforms can work with Rock Cloud.
So yeah, right now we support it once you generate the LAS, and then you can upload to the Rock Cloud, and you can get anything you want: the contours, digital elevation models, power lines, all these different products, or just hosting it and sharing it. That's also something that, like I was saying earlier, just organizing my data has been, just nice to have something that I visually organize it.
Okay. Let's talk turnaround time from when someone uploads some data, because Alex actually said you immediately get this one view. But what is the turnaround time on a typical project to get these deliverables?
It's about a day. It's about a day turnaround. So, similar to like a drone deploy or something like that. It's about a day is what we're hitting.
Okay. So let's see. Let's just kind of circle back here to Gabriel. On the hardware, how and where are RTK antenna and LiDAR sensor location offsets taken into consideration?
Exactly. So that actually, so someone has processed some LiDAR data before. So there is this antenna offset. So the quality of the trajectory of your LiDAR system through three-dimensional space of the air determines the quality of the data on the ground. And so you have this GPS, and that's located far away from the scanner. So all these things need to be known where they're offset. So on the M200, M210, M300, we just tell you where to put it, and we know that offset, and that's all contained in our software. We also can compute that lever arm offset for unknown offsets. So yeah, we verify that every time we process. That's like one of our first QC QA steps in the Rock Cloud.
Okay, excellent. I mean, that was definitely above my skill level to answer that
Yeah,
question.
this is, most users, we're just going to tell you, here's the GPS, just put it right there. Or in this case, I'm connected into the dual DRTK on the M200. And so you just kind of we have a drop down that selects where you put that GPS.
I mean, because I'll definitely say, as a dealer of the aircraft and the systems, LiDAR has been a massive challenge for us, because not only does a typical customer want the equipment, they want to be trained on how to deal with the data. And that's just way beyond the scope of what we can offer here. But I think Rock Cloud just, man, this is kind of a game changer, I think.
Yeah, I'd say both the Rock Cloud and then also the community, having people answer questions, pose different questions. If you have a question, the free community, go on there and ask them, and you'll probably get an answer. So having that as a resource is certainly super helpful.
Can you show us some other cool things that Rock Cloud can do?
So I think let's see.
Yeah, while you're showing that, Alex, I'm gonna just talk about how even myself, I've been doing this for years. I still, on like my other systems that I fly before the R1a, I'll get to a job site and I can't tell you how frustrating it's been just getting there and having a freaking Ethernet cable is the thing that breaks, that prevents you from flying. That's happened like 3 times to me. And then, or having just a stupid USB cable. Like, I don't know, man.
Those things happen.
I have years of grievances with other stuff.
So yeah, if you can just kind of walk us through what this interface is showing us, I think that'd be pretty rad.
Yeah, absolutely. So I'm just kind of going in here. So we have this flyout here that has kind of some general information. We're building more every day into this interface to allow it to be easier to get information and configure things. My internet's a little slow right now. I think I'm using all my internet with my video maybe, but so it shows the point cloud here. It's not loading. Let me try refreshing.
Refresh, yeah.
Yeah, I think I might be hitting the edges of my bandwidth. Here, let me see if another one's already preloaded. Yeah, I was on this one earlier. Might be cached. I think my kids just got home, and I think they're streaming. Yeah. But I might be at the edge of my bandwidth. So we'll see if it loads up. But what I was going to say is that we have a team of developers that are kind of working on the cloud, making it easy to use, easy to share data, view your data within this interface. If my internet keeps working, you'll see that you have some ability to, if you get a classified data set, you can hide the trees, just show the ground. You can do some measurements on that interface as well. So yeah, we'll see if my internet comes up, but.
So yeah, a few things, it's having those ground control point report. So yeah, I'd say typically a customer, they're going to ask, the way I would go in and win a job, you tell them that, hey, we can deliver contours. That's something that everyone understands. They know what that means. And then from there, you start talking about the LiDAR a little bit. And they're going to ask some very basic questions. They're going to say, there's like on these big companies that have been using LiDAR for many years, they're going to ask some very typical questions, say, what's the sensor? What's the IMU in there? And then you just give them those accuracies, which is all listed on our specs on the website. So if you just give them those specs, they go, okay, cool. It's kind of at this point where there's a lot of subjectiveness in LiDAR, in my opinion, just because usually those are the only questions they're going to ask you. Then you go out there and you get the data. We have a base station, so that's something we haven't talked about. There is a base station. We're using the IMLID, the Reach RS2, but we also use Trimble, we use TopCon, CHC. So if you already have a base station, you can just use that. And I believe the DJI base station works as well. We just need the RINEX data. And so you put that base station up typically on top of a surveyor's monument, or you're going to calculate that precise point, yourself. And so all the data is going to be precise to that point that you put that at. So typically we're going to be working with a surveyor that's already come out and laid down control for us. And we just put our base station up right on his point. He tells us that number and you put that into the Rock Cloud when you upload the data. So, and if not, you can use, if you're in America, the US, you can use the Opus correction system to get that precise point location, or you can be using an RTK in-trip network, some casters, or you can be taking a measurement for a really long time, like 24 hours, and calculating that point yourself. Now, if you don't do that, the data is going to be all internally accurate. So measurements are going to be good in the data set, but the whole data set could be located up, down, left, or right, by as much as, a foot or more, something about this amount. And that's just limitations of GPS. It's the same thing that happens with all RTK or PPK, systems. It's just, that is what GPS is, unless you do that correction. So you can see here in the cloud, Alex is showing this Claremont Canyon data set, and he's doing a little measurement. Alex, why don't you go ahead and show go ahead and show this off.
Yeah, so I'm just showing a couple of measurements while Harrison was talking. I think my Wi-Fi stopped working, so I turned that off. I'm also connected on Ethernet, so that's a lot faster now. So I did a height measurement. So I just did a height difference between this location on the road to the top of this hill, just as an example, shows 28.97 meters height difference. Also just kind of measured kind of close to this car here, front to end, 5.23 meters. So you can do kind of simple measurements like that in here. You can do, so if you want, let me do this real quick.
All these other points that you're seeing on here as well, those points are ground control points that the user uploaded. So it populates those ground control points onto the LiDAR data set. So you can actually go into this viewer and see for yourself as well.
So I got a question. Are there any issues with, I guess, environmental conditions such as, ice or water, snow? Do any of those types of conditions affect the performance of LiDAR?
So yes and no. So on our sensor, the R1a, we just flew it on a glacier up in Alaska. Really cool video coming out in Neon Drones. I got onto a helicopter and landed on a glacier and tested it out, mapping this glacier front. And so ice, snow, it looks great. The returns are very, very strong, and it works really well. Now, that's a problem with some of the higher end Regal systems. They use a different frequency laser, and that frequency, it's like 1500 nanometers, actually will absorb on the ice and snow. So you won't see ice and snow at all on that system. Water, you're not going to see water. You'll see some reflections when you're directly above water, but for the most part, water will absorb the laser pulse, and you're not going to get a reflection off of it. Black road top looks good.
Hole?
It's just going to be a black hole, exactly. So you're still going to get the shoreline all the way down to the water. It actually really helps getting the shoreline because you're going to get all the data up until the water. And you'll see that really evident in the data set. Power lines look good. Buildings, street sign, vegetation, all these normal kind of conditions. Ice, snow looks good. Just water is really the big one.
Yeah, I think as you mentioned earlier, you were literally just up on a glacier doing some LiDAR
really
work. So that, that was all ice and white snow. The data set looks amazing. So we'll be publishing that here in the next few days when that video comes out. But yeah, definitely works.
So are there certain conditions that are better for shooting LiDAR or not? Like thermal, doesn't work in fog. The water's just going to block it. Photogrammetry, you don't want to do it early or late or at night. You want the sun straight above so that there's no shadows. Are there variables like that can affect LiDAR performance or efficiency?
So it's actually pretty robust to most of those things. So yeah. I flew the R1a, that Bixby Bridge data set. I was actually evacuated. That's whenever the Santa Cruz fires erupted. And I was just south of Santa Cruz fires and I got evacuated. And then I actually went, and it was before there was a NOTAM closing off the airspace. And I went and flew some of this fire through the smoke. And so the only thing that you're going to see is you'll get a few spurious points up in the air, but for the most part, it didn't matter at all. It still saw the ground very well. So even in that, now I think if you were in the smoke, like straight up black smoke, couldn't see the drone, yeah, I might have difficulty seeing through that. But
you're probably not going to be flying too often then.
Yeah, but fog wasn't a big deal. I'm in San Francisco, so I've flown it in the fog, and we've flown it in the rain a little bit. Not a big deal.
I'd say that one of the big differences is, so like this Alaska job, right now, the sun is not staying up very, as long as it is in the Mojave Desert in Alaska right now. It's pretty shallow angle. So we had to get photogrammetry for that job as well. So like we had to kind of block out good times for photogrammetry, but we could do the LiDAR, much earlier and much later in the day. So like even getting close to dusk, obviously we still had to see the drone and everything, but you can fly it much later.
LiDAR works better at night.
I was going to say, there's no technical reason why you couldn't do LiDAR in pitch black, right?
It would be great.
Technically, it would actually work better. So one of the things, like the color of this laser actually is covered by some of the sunlight. So no one would ever see that in the data set unless they were like a laser scientist who was looking for these things. So yeah, no, it'll look about the exact same to anyone.
I mean, that's a big advantage. Is
huge
really
advantage.
Not being limited by a time frame that's optimal for flying a particular mission.
Totally, and something that we were uploading. So we just finished the camera integration with the R1a. So now every R1a is going to be coming with a camera, and so it automatically colorizes all the point clouds, and it looks quite astonishing, just like an orthomosaic when you're looking at the colorized point cloud. It looks really beautiful. So even if you're looking at trying to find like cracks in roads, stuff like this, like you're going to see it very apparent in this data set. And that's something else about LiDAR that photogrammetry doesn't do. So you actually get this, if you want to open up the runway airport data set, Alex,
yep.
This is something we haven't mentioned yet, but it is really important. It's the fact that you're getting intensity back. So the reflectivity of a surface, so black is going to absorb light, a mirror is going to be a perfect reflector, and white is really good as well. So that the amount of light coming back is the intensity. And so on this data set, this isn't colored at all. This is actually the intensity of the laser coming back. So you're able to see all this paint. You can see the road markings, which you should, because these should be high reflectivity markings. And you actually can zoom in. You'll see cracks in the road. You're going to see kind of at the crack joint where there's some water seeping through, and it discolors that surface. So that's actually used quite a bit in some more advanced LiDAR analysis applications. I think it just looks really pretty too. But yeah, Carrie, so I think what we're doing here at Rock Robotic and the R1a and the Rock Cloud, definitely changing the game in this industry. And the results that you're getting out of the system, I have buyer's remorse from some of the systems I bought, spent almost $200,000 on. And because there's not a single customer or client that we have that would ever even know the difference. You know, they would never say, they'd never know.
Well, I'm looking at this screen right now, and this reminds me of something else about the LiVox sensor itself. When you're using a more traditional, spinning drum laser, you're getting basically one line at a time as it's scanning, where the LiVox sensor is doing this like cloverleaf pattern, and we can kind of see that in this image. Is that what I'm seeing here?
Yeah, and you can kind of see it a little bit more at the edges. You can kind of see it at the edges of the data set. Like the flight line is somewhere over here, maybe over here. So you can kind of see it here. So it's a clover leaf that doesn't ever, so it spins as well. So it's not a continuous same clover leaf pattern. It random.
Non-repeating, yeah.
Exactly. Exactly. So you get like just really great coverage with that pattern.
Yeah, and also, so I did a video comparing another LiVox-based system versus a Regal on, and the vegetation penetration of this system, it's just as good as my Regal. I mean, there's really not a big difference.
That was a very interesting video. When you were, zooming in and actually looking at accuracy data, because you were throwing so much of the other data away because it wasn't looking down, what you ended up with was extremely comparable numbers.
Yeah, absolutely. And I don't think Carrie, the world's changing.
It's an exciting time. I mean, I've been watching LiDAR for the last few years, and when we've had customers that are interested, I've really just gone, go talk to LiDAR USA, go talk to these guys over there. And usually once they see the price tag, that's pretty much the end of that conversation. And that's why this is, literally like the last 3 months have been so exciting in LiDAR. It's just these new systems that are coming on board, your product, the Rock Cloud, making processing, I don't know about easy, but definitely accessible, to way more people. This is an amazing time for anyone who's interested in LiDAR.
Absolutely. And as you guys stay tuned with us in the future as we keep going down this road, we're going to be putting out a lot of content around just getting jobs, winning jobs, about how to actually quote jobs. So, we want to be transparent basically from all the way from the hardware down to your clients and customers that you're selling to. Whether you're internal to a big business and you need to sell internal, or you need to go into the office of another business and sell to them. We've been doing this for years, and every customer is happy with our products, and we're going to be able to help through our community, through this YouTube channel, just the whole environment of how to knock out this work.
Yeah,
so there's more to come.
Yep. So some great ways to get in contact with us. You can go to rockrobotic.com. There's a little chat bot down here. We get all those messages. If you click that, you can send it there, or contact, or alex@rockrobotic.com, or harrison@rockrobotic.com are two good contacts. If you have general questions, like we mentioned earlier, a little plug for our community, you can certainly ask the questions up here. There's lots of great information already up here for you all to take a look at. Certainly reach out if you have questions. If you have any other questions today, I'm happy to stick around.
Yeah, with that, if anyone has questions about the hardware, the processing, the workflow, or anything like that, feel free to throw some questions out there. I do have one. Is there any type of like trial account or demo account that someone can create and play around with those sample data sets?
Yep, so if you just go to cloud.rockrobotic.com, a little screen will pop up where you can create an account. You can log in if you have a Google account or a couple other shared providers. You can sign up right then, and then you'll have the exact same thing that I walked through today. All of these data sets you'll be able to take a look at. You'll be able to use the viewer. You'll be able to, really, you can download the LES files or the shape files and plug them into whatever software that you currently have. If you have other software you want to use, but yeah, you'll have this exact same interface here.
Okay, let's see what John's asking here. Oh, this is how is the R1a installed on the M300?
Yeah, so
same way, right to the Skyport.
Yeah, it's so
literally the same as
simple.
An X5 or XT2.
Yep. Put it on,
plugged
turn it
right onto the port on it.
Yeah, but it grabs all the power
Plug
from
it in.
that, and then that's the mount as well.
Super simple. Now, on the 200s and 300s there, do you put that alongside with something else on a dual gimbal, or does it really need to be on a single gimbal mount?
Funny you bring that up, Kerry, because I was just talking to Alex, and I was going to put because I have the X5S right here. And yeah, no, I was just about to try this out. We haven't tried it yet, but I was going to take this X5S and put it on there and see, can I do photogrammetry? So we're doing photogrammetry on the LiDAR itself, but I just kind of wanted to see if I can use this camera as well.
Huh. So,
do it right now.
it'll physically fit alongside with something else, but in terms of functionality and stuff, it'd be interesting because the field of view of the different cameras is going to be different. You'd have to make sure you had enough overlap of the smallest one to make sure you were collecting the right amount of data. So yeah, John, I'm glad you asked because I just kind of assumed because we had mentioned that it was Skyport, but it is as plug and play as it gets. But since we're on that, and Harrison, since you have it right there in your hands, what's kind of what's the getting started process right there?
So getting started, basically all you do is you take the R1a out of the box, connect it on the Skyport, just like the X5S. You do plug in this antenna. So on this one, I'm using the actual DRTK antenna, plug that into the device, and I have a little Wi-Fi antenna here. Power up the drone, and then there's a power button on the device itself, and then you're good to go. So once it's up and running, it has a Wi-Fi hotspot. You pull out your phone, and you can actually look into it and see all the settings, turn it on, and about 5 seconds later, you're starting to collect data.
How are you planning that mission?
That's a very good question. So I've actually created a bunch of custom cameras inside of GS Pro. I'm using Maps Made Easy. I'm also playing with some Pix4D software capture. And so I just made a custom camera and we're putting that on the documentation. So once that custom camera is there, you can just say the overlap you want. And that's literally the overlap you're going to get on your LiDAR data.
So that would be the same on the M300. You just create a custom camera within the Pilot app.
Exactly.
And that's what we did up in Alaska. And yep. So yeah, we just really simple. I just flew a terrain following mission here behind me. It goes uphill about 30 meters, and so I used the Maps Made Easy app, and I just drew the polygon and started flying.
So what kind of flight times are you getting on the M200 series and the M300 with the R1a on it?
M200, super hot. I don't know. I'm getting a couple minutes short right now. But today I was flying probably about like 18 minutes, something like this. And then on the M300, we were getting easily 35 minutes.
Oh, wow. That's great. Now, that's actually where you're at right now. So what's your altitude above sea level there?
We're pretty low. I mean, I think in feet, I think it's like 2,500 feet here. I saw a sign coming in.
Not like back here at home. So back here at home, because they're from Colorado, right? So we're typically flying 6,000, 7,000, 8,000 feet. How does that affecting your flight time?
Well, we flew the M300 up in about, was that 9,500 feet, Alex?
Yep.
9,500 feet. And yeah, it just maybe a minute less. I mean, it really wasn't bad at all. And we also had quite the storm come in. I mean, we had like 50 mile per hour gusts come in as we were flying. But that M300, the M300 is really awesome.
And you're telling that to the guy you borrowed the M300 from. Good, awesome.
I mean,
it came back in one piece, Gary.
It came back in one piece.
Yes, you didn't have to buy it at the end of the day.
No, but we flew up in Alaska this past 2 weeks with the M300, pretty much solid. And hot swapping the batteries is really awesome. So you just come down, basically, pause your mission, come back, land, hot swap the batteries, keep flying. LiDAR just stays running, no problem.
That is a good advantage on the 300 now, is not having to sit there and reinitialize everything before you take back off again.
Yep.
Now you can hot swap on the M200 as well. You need to keep your thumbs really hard pushed on those batteries.
Right. It's not as simple as they made it out to be.
Earlier today,
you have your battery callus on your thumb?
Yeah, no, I actually killed the system earlier today after doing 2 consecutive flights, but it didn't matter because basically the data every like half second is being stored. So even though I hard killed the system, all the data is still there. So.
Right, but on the 300, it's dead simple now.
So easy, man.
It's almost Harrison proof.
Almost Harrison proof. I mean, I did screw it up, but
All right,
guys. The M300s. Yep, cool.
Go ahead.
I was just gonna say a few things about the M300. I mean, that FPV camera that's on there. I mean, we were flying a good solid 3 or 4 kilometers away from us, and it was no problem. I mean, 1080p coming through. The obstacle avoidance on every side is really sick on that system. So if anyone wants to buy M300, Multicopter Warehouse is the place to go. Those guys will take care of you. They took care of us. And I've been I love it. Yeah. It's going to get better. It's the same thing with every DJI. DJI does this. They release their products and their first buyers are their guinea pigs. So yes, there are some things like mission planning leaves some things to be desired. Some of the functionality on the controller, it gets a little annoying because it doesn't have any third-party app support yet. But this is the same thing when the M200 came out. It was the same thing. Inspire came out, the same thing. So the third-party apps are going to be supporting it soon. I wouldn't worry about it. I think it's going to be, the platform's just going to get better over time as people start supporting it more.
Well, there's already a couple, but the apps need to run on an Android tablet that you connect to the Smart Controller Enterprise. So it's kind of a workaround, but that's at least it's a start to add some third-party support to it.
That would explain why my iPad did not control it.
Nope, it's got to be Android.
Okay.
Guys, thank you so much. I mean, I think this has been really informative. I learned a few things, and I hope the people who joined us today learned a little bit more about LiDAR, its strengths. There's not too many weaknesses to it, but I mean, there's pros and cons to every system. I mean, the definite con is the price.
Absolutely.
Compared to something that you can do with a Phantom 4. But this barrier to entry is just falling rapidly, and it just seems like a really good time to start looking at this for your business out there to see if this is a service that you can add. And this is not, $40 jobs. This is big money jobs, right?
Should we say how much we're making today, Alex?
Maybe cut it in half and tell them.
I mean, these are big money jobs.
Today. Big money jobs.
Yeah, big money jobs.
Right. So
I could buy the R1a with today's job.
Yeah, and that's the thing about these. These types of jobs do pay for the hardware very quickly.
Mm-hmm.
Yep.
So it's a big investment, but at the end of the day, you're able to offer something that not everybody who can walk into my store and buy a Mavic 2 Pro and go start doing tomorrow. You know, this is a very specialized set of data that you can deliver to your customers, that they can take those deliverables and drop right into their CAD software and start working with that data immediately with an accuracy that is exactly what they need to get their jobs done.
Couldn't have said it better myself, Kerry. You're absolutely right, man. Yep, that's it. Well, we hope to get more people in this LiDAR industry and, you know, be sharing our war stories and hearing some from all you guys too. You know, definitely come over to the YouTube channel and leave some comments and harass me over there. Make fun of me, if you will.
There's a lot of very fun videos over there. That's kind of our niche.
I mean,
it's creating.
It's actually hard to believe that they've made learning LiDAR rather entertaining. So go to cloud.rockrobotic.com, sign up for an account, play around with that sample data. I think it's just fascinating to see what you can do with LiDAR data, with being able to remove structures and trees and get right down to the terrain. I think that's just mind-blowing to me, you know, that you can do something that simple, you know, or as easy as it is in just a web browser. And of course, Indiana Drones on YouTube, check that out. Awesome information over there. That is actually how we got together. Is I saw their videos. I'm like, guys, we need to talk. You know, I need to have you on the webinar and, you know, teach some people about what's going on and the advantages and, you know, how to use LiDAR. Because I don't know that there's anyone out there that not only has the skill set and experience that these guys have, but they have the ability to educate in a way that you don't fall asleep. So thanks, guys. Really appreciate you taking the time to join me today.
You bet. Thank you.
Thank you, Kerry.
All right, and everyone out there, thanks for joining. Really appreciate you spending a little bit of your afternoon with us. Be sure and check out multicopterwarehouse.com. We just relaunched our e-commerce site, and we're very excited about the new look and feel of everything. And we'll catch y'all later. Bye-bye.
See you guys.